So we are asked, for this sequence here, e to the 5n over 3 minus e to the 2n, we're starting at 1, going to infinity. At infinity, does it converge to one value, or does it diverge to a different value? So let's go ahead and do that, and let's determine if it really is convergent or divergent. And if it's convergent, which value are we converging to? So to do this, we're going to take a limit as n, our variable, approaches infinity. So e to the 5n over 3 minus e to the 2n. So is it converging or diverging? Well, let's plug in infinity. So e to the 5 infinity is infinity. 3 minus e to the 2n infinity, or n is infinity. Well, that's infinity. This is indeterminate. This limit does not exist here. Well, it's indeterminate. You can't determine if it exists or not. Okay, because infinity over infinity. Does it exist? Does it not exist? I don't know. It's infinity over infinity. So let's go ahead and use a rule known as L'Hopital's rule, which says that for, and in case you haven't learned L'Hopital's rule, if we have a function over another function and we're asked what's the limit as x in this case approaches some value a, and we get an output that's 0 over 0 or infinity over infinity, well, we can rewrite this as f prime of a, g prime of a. We evaluate both functions at a, and that should give us some output that is what this is equal to. So that's the idea behind L'Hopital's rule. Let's go ahead and do that. Okay, so when we take L'Hopital's rule, I'll do L prime. So let's do this. It's going to be 5e to the 5n. The 3 is going to cancel out. And then we're going to get negative 2e to the 2n. Notice we have some like terms we can cancel. There's not additive terms, there's not subtractive terms, so we're allowed to cancel top and bottom if we have anything similar. Well, notice we have 5n over 2n. Remember the quotient rule for exponents. If we have n to the first and we have n to the second, we can subtract this, so this is really equal to n 1 minus 2, or n to the negative 1. Does this idea make sense? Hopefully it does, because we're going to use it here to make this limit a lot easier. You would have to do, like, if you didn't use this method, you'd have to do a comparison test, and that is ridiculously annoying because, like, oh, you have to find a function that's always greater than this one or something in between. It's really, really, really annoying. So we won't go ahead and do that, but we're going to use the idea here, and we're going to say, okay, well, we can cancel 2 of these on the bottom. So this is going to really be negative 5 over 2e to the 3n. Does this idea make sense? Now let's evaluate it as n equals infinity. What's the limit really equal to? It's negative 5 over 2e to the 3 infinity here. Okay, and what this outputs is, okay, well, 3 to the infinity is 3 times infinity, which is just infinity. E to the infinity is infinity, and I don't care what it's times by, it's always going to be infinity. So this value is infinity. It's divergent. Okay, so this limit, our sequence, no matter what we plug in, as we approach infinity, it's just going to go up to infinity, and it's going to go away, and it's diverging away, not converging to a single value. Hope you guys enjoyed. If you did, please drop a like, comment, and subscribe. I hope you have a wonderful day.